So this week we'll be exploring the different concepts associated with evolution. And we have a whole bunch of them that are listed on that big table. I'll just show it to you very briefly here by scanning over to my computer. This table right here that I'm showing you on my screen, that blue one that we'd like you to fill out with the definitions and the implications. I'll do the first line for you just to kind of demonstrate what it is that we'd like you to do, and then the idea is that you'll continue for the remaining definitions. So the first thing we need to know is what is a bottleneck. And I Googled it, so I did genetic bottleneck, and I came up with the definition of a dramatic reduction in the population such that the allelic frequencies change from the initial time zero. So the idea is that this could be due to generally some kind of natural disaster or human activity where really the variation in a population changes quite dramatically. So let's just very quickly kind of draw this out. We have a whole bunch of black X's here in the population, and we have a whole bunch of red ones in different different frequencies. And I'll do a dramatic example just to kind of make it a little bit more illustrative of what we mean by a reduction in the variation. Let's imagine that there's some kind of natural disaster, some kind of disease or something that dramatically decreases the population. So let's go right through like this, and there we go. We've had a dramatic reduction in the population where the number of individuals has decreased, and we happen to have lost the red X's. Which means that there's been a change in the variation. So evolution has happened, there's been a change in the variation that's present in conjunction with a dramatic reduction in the population. So the question is, was this random? And my wiping it was not random. We all saw me do it. It was all caused by something. But when we ask whether or not it's random, we don't ask with reference to the cause, but rather with what is removed from the population. So the question is, who was removed from the population random or not related to the variation that they had, the genetic variation that they had? And in this case, the answer is yes. With a bottleneck, the answer is that it is random. And so, it wasn't because those X's were red that they got removed, or because they were black that they were able to survive a little bit more. So the answer is yes. The question then, the next column, is what happens to the variation associated with this particular effect, and in this case the variation goes down. Here we're asking for the number of populations that result from that particular effect by definition, and you can see that we haven't increased or decreased the number of populations, we've just reduced its size, and so the number of populations remains the same. And then, of course, because there hasn't been a change, we wouldn't fill it out for the genetic difference. So that's how you do the first row. We're going to ask you to do it on your own for the remaining definitions.